Hey, AP Physics students, how about a couple of hints about T3.3, which is page 87, number 73, and page 101, number 17. First of all, number 73. It's about a lunar lander, and we would like to discover the thrust force that is needed to make this thing stop and not crash into the lunar soil. So in order to slow that down, we have to know the acceleration. So hint number one is the acceleration is a question mark. In unit one, we have some formulas, several formulas that have acceleration. But remember, the best trick is to figure out the knowns and the unknowns in this circumstance. So it's moving at 18 meters per second. There's your V0. So we've got V0 is known to us. Certainly V, the ending velocity, ought to be 0, so you can stop that. And we know the, in this circumstance, we know the exact displacement of this, and so we know the delta x, or you could call it delta y in this case. So find the acceleration first. Then it's about F equals ma. And I'll only say one more thing. Every time you have these circumstances, if you can draw a free body diagram, it's useful. The landing rocket has an upward force that we wish to find out. And it has a downward force of gravity. Now you have to combine them. This upward force minus the m times g gravity force is the entire left-hand side of the equation. Then you should be able to find, hopefully, by using F unknown minus mg equals ma, should do it. I hope that helps. A little tougher question is number 17. Let's look at this. The hammer throw. So there was a hammer throw. This is an Olympics competition, and there was a world record for this. And that hammer is twirled in a circle, and we want to know the centripetal force. So the centripetal force. Now, since centripetal acceleration is v squared over r, the centripetal force would be mv squared over r, and that's just fine, except we don't know what the velocity is. That yields a projectile motion question. Let me give you a couple of hints. First of all, we know the delta x. So that formula, delta x equals vx times t, very useful. The unfortunate thing is we're looking for vy, or excuse me, v0. And so we don't know what that is, and we have to work backwards a little bit. The Vy formula, as you see it right here, involves the following. At the top of the rise, the velocity is 0 vertically. So that's why I put a 0 here. The beginning velocity is whatever V0 is sine of 41 degrees. Logically, we're talking about this part right here involving the sine. Gravity is negative 9.8. This gives us the time to the top. All right? Well, of course, the time you cover delta x is twice that. So if you double this number and substitute it there, you could solve for v. That's the end of my hints. Good luck.